All right, guys, we're on the lesson 13, representing data. We're going to talk about representing sets of data using different visual displays for this lesson. So let's make a bar graph. That's the first one we want to talk about. So if you have some information here, we have sports, different sports, basketball, football, soccer, baseball, and how often they occur. Basketball, football is 25, so forth and so on. So to make a bar graph, you draw a horizontal axis and a vertical axis, label the axes, and then add the title, and then draw bars to represent each sport. The vertical scale is the number of students who chose each sport, and the horizontal scale identifies the sport. So right here, you have a vertical axis that tells how many. The horizontal axis, you just list the different sports. Okay, and notice we gave it a title of favorite sports. Okay, and that's one way to display the data. And real quickly, you can see that the favorite sport out of all the favorite sports was football, and the least favorite was basketball. And soccer and baseball are pretty close. A cumulative frequency for each event is the sum of its frequency and the frequencies of all preceding events. A histogram is a type of bar graph used to display numerical data that have been organized into equal intervals. So a histogram would not make sense here because a cumulative frequency really wouldn't make very much sense, and you'll see why in a second. So let's make a histogram for the frequency and the cumulative frequency. So this is the age at inauguration, and this is the number of US presidents that were that old when they were brought into office. Okay, so these are age ranges. So the cumulative frequency, so if they're less than 45, which is 40 to 44, there's two of them. If they're less than 50, which is everybody up until 50, you would add these two. And then less than 55 is everybody up to 55, but not including it. So you add all three of those and keep going until you get to all of them. Now make each histogram like a bar graph, but with no spaces in between the bars. So you have your horizontal axis that gives you the age ranges, and the vertical axis that gives you the number of presidents. Now this is just a histogram, okay? And you could see that it kind of peaks at between 50 and 54 and 55 and 59 as their ages, and then it kind of tapers off. Now that is a histogram. Now, a cumulative frequency histogram is going to look like this because you're adding each previous one into the total from that point forward. Okay? Another way to represent data is by using a line graph. A line graph usually shows how data change over a period of time. So sales at the Marshall High School store are shown in this table, and let's make a line graph. So September, October, November, all those months, this is how much they sold. So draw a horizontal axis and a vertical axis and label them as shown and include a title, then plot your points. And then draw a line connecting each pair of consecutive points. So across the bottom is the month. The vertical axis is how much they sold, and we're talking about school store sales. So in September, you could see they had a really high amount, and then October, November, December, January, February, March, April, May, it kind of like fluctuated, but it was way lower. And my guess is that in September, that's when school is starting, so a lot of students are buying more things in September. And then October, you already have your school supplies, so you probably don't need too much. Maybe you ran out a little bit in November, so you bought some. December, usually you have a nice big long winter break, so you're not buying too much. There's less school days there. January, you're coming back. February and March, you're getting more. And then towards the end of the school year, you're not going to be buying as much because your school year is going to almost be over. So that's kind of how we can interpret that one. Data can also be organized and displayed by using a stem and leaf plot. In a stem and leaf plot, the digits of the least place value usually form what are called the leaves, and the rest of the digits form the stems. So let's make a stem and leaf plot of the speeds of the fastest land animals and check it out. So the least place value is the ones. So 32 miles per hour would have a stem of 3, so the tens place, 3, and a leaf of 2. So here's your stem and your leaf. You put all the stems on the left side, put them in in order. So if you notice, our numbers go between the 30s and the 70s. Okay? So we have 3, 4, 5, 6 representing 30, 40, 50, 60, 70. Then the leaves are the ones place for all the 30s, 40s, 50s, 60s, and 70s. And you put a little key down here to interpret it so that you know, or the person reading your graph, your stem and leaf plot, knows what 3/2 means. Okay, so 3/2 means 32. Now, if I have 4 and this 5 means that represents one of the animals that was 45 miles per hour. Notice there's 2 5s, so that represents 2 45-mile-an-hour land animals. There's 3 5 zeros, so that means 3 animals can go up to 50 miles per hour. All right, so that's it for this section, and can stay tuned for the next video.